Welcome to part 1 of Competency 13 quiz. Number 1. In a particular group of hospital patients, the probability of having high blood pressure is 3/8. The probability of having a vascular disease is 5/12. And the probability of having both is 1/4. What is the probability that a patient in this group has either high blood pressure or a vascular disease? Okay, the first thing we need to know is there saying or. That implies addition. However, remember, it's one or the other, but not both. That's where the 1/4 comes in. Okay, this implies that we have to do this. We have a fraction, so we're going to say 3/8. Then we add it to the next 5/12. So we're adding the high blood pressure and the vascular disease. Those fractions that are given. So let's add that. Okay, then 5 out of the 12. Now that's one or the other, but we have to subtract out where they would both occur. Okay, so subtract, and that is 1 out of 4. Okay, if you're not familiar with what I'm doing, we discussed this in a prior video within Competency 13. Okay, let's keep going. Let's enter. Okay, there we go. 13/24 is option C. Okay, let's look at number 2. Each letter in the word market is placed in a jar. If the letters are drawn one at a time without replacement, that is going to change our denominator. Okay. What is the probability that both vowels will be the first letters drawn? Okay, so what are we going to do here? We are going to have a fraction. Well, we have 6 total letters, 2 vowels. That is 2 out of 6. And yes, you could reduce it, but it's better when you're testing not to reduce anything. That's why we have a calculator that does a lot for us, okay? All right, so now we have that, okay, and it says both. Both implies, both of them implies and implies multiplication. So we are multiplying. So now we have another fraction. Now what's going to happen on the next go? Now here's the thing. You have to really think this one out. It says first. The vowels will be the first letters drawn. Okay. So we've already drawn a vowel and we put it off to the side. How many vowels do we have left? We only have one left. And how many total letters do we have? We only have 5 now. Okay, so let's push enter, and that's 1/15, which again is option C. Okay, let's go to number 3. Number 3, in a game of cards, a player is dealt 3 cards. What is the probability that all 3 cards are picture cards? Okay, this is kind of like the last question, like number 2. And we have to think, okay, how many picture cards are there in each suit? There's 3. How many suits are there? 4. So there's 12 of them. So let's set up our fraction. We have 12 out of 52. Okay, now wait a minute. That's 1. We've drawn once. And this implies, I mean, it's just 2 sentences, but it implies and a picture card, and then another picture card, and then a third picture card. So we are multiplying. Let's set up our next fraction. Okay, so how many picture cards are we going to have left? Well, we just drew one. So we only have 11 left. And wait a minute, we don't have 52 cards anymore. This is implying without replacement because you're dealt the cards and you're holding them. so you aren't putting them back in the deck. Okay, so the implication is multiplication and not replacing. So that means 51 cards. And now you have to do this a third time. So time, set up your fraction, 10 over the 50. Okay, and let's push enter. Okay, now that is a pretty serious decimal. And all we're given is fractions. That's okay. Now, I want to warn you that for this fraction, look at how intense it is. It's pretty small. So when you push your toggle, you're not going to get anything out of it. That is fine. You still could be correct. So the first thing I need you to understand is look at your fractions. I know that option B and D are going to be a larger fraction, a larger decimal, rather. So I don't think those are what I want to test. I'm thinking A is the best one. So there's our value. Let's set the fraction up for A. 11 out of 1105. Let's see what we get, and they're exactly the same. So don't think that when you're just because a calculator gives you something different that it isn't the true option. Okay? Because the reality is you could do some reducing individually. But if you did that, you'd waste time on your test. You only have 3 minutes per question. Okay, and obviously C isn't an option either. So put that in 11 over 221 and we're gonna have to toggle. Absolutely not, it's too large. Okay, let's look at number 4. A company director wants to randomly select 4 employees out of a list of 12 for a trip. How many groups of 4 employees can be created from the 12 employees? Well, that's a combination because obviously order doesn't matter. Okay, so let's do that. Let's see how many total. 12. Prob. Now it's a combination. We want number 2. And then how many out of it? We want the 4. Okay, let's push enter. 495 different combinations of 4 employees out of the 12. Wow, that's quite a bit. Okay, all right. Now let's look at number 5. Yeah, let's go to number 5. Okay. 9 people are to be seated on one side of a long table. Sarah and Amy cannot sit at either end of the table. In how many different ways can the 9 people be seated? Okay, don't let this upset you at all. Okay? First off, on each end, that means you only have, out of the 9, you can only sit 7 of them. Okay? But you need 2 out of the 7. So this is what we have. Oh, and by the way, because it says one side of a table and you have people, once you pick a person, you can't choose them again. Okay? That screams permutation. All right? So let's talk about the 2 ends and the 2 people. Don't let that confuse you. And there's a couple ways to think of this, but this is probably the best. Okay. First, you have 7 people on each end, but you only want 2 of them. Then you're going to multiply that to the 7 out of 7. Okay. So once you select those 2 people on the end, you have you have to subtract them out of the groups. You have really what you have 2 groups. Think of it as 2 groups. Well, I have 2 groups. Well, I only want 2 out of this grouping. And then I have the ability to do 7 out of 7. Okay, just think of it that way. It's probably the best way. Okay. Now here's another way. And we're going to do them both on the calculator. Okay. I am going to say, all right, I am talking about the 2 ends. I have a possibility of 7 people. Okay. Now, once I choose one out of that 7, now I've got 6 people left for the other end, one or the other. Okay. Now I've got 2 people out of those 9. They're done. Okay. But now I have 7 people left to put in those 7 middle seats all in a row. Well, that is 7 factorial. Okay. Remember, permutations and factorials, they are the same thing. It's just you have to know how to handle them. Okay. All right. So let's put these two things in the calculator and see what we come out with. All right. Now, I know it's a little confusing that we had 9 people, but really we're taking those 9 people and grouping them. Okay. And from those groupings, we have a permutation. Okay. All right. So let's see what we got here. I'm going to say 7 prob. Number one's what I want. Type in 2. Remember, I have to multiply. Then I have a 7 out of 7 permutation. 7 prob. Number 1. Or you can push enter. Either one. Push 7. Okay. Now that gives us option B. Absolutely. Okay, so I'm going to go ahead and circle that. But let's go with this next way to deal with this. Okay, so on one end, I have 7 possibilities. Now, I already placed somebody there. Now I have 6 people left to choose from. That's at the other end of the table. Remember, I have 9 seats total. So this person, I have one person on one end, one person on the other, but now I got to deal with all those seats. I have 7 seats in the middle. So that is times 7. Now go prob, and I need number 3. Okay, now let's push enter. And voila, we have the same answer. So if you can wrap your head around that, it's not tough. This calculator is really great. It helps you get through that very quickly. Okay, let's try number 6. Number 6, a circle is bounded by an equilateral triangle with a base of 6 square roots of 3 and a height of 9. The radius of the circle is 3, which is perpendicular to each side of the triangle. What is the probability that a randomly selected point that lies inside the circle will also lie inside the triangle? Okay, this is a part over total in disguise. What's the part? The circle, and the total is our triangle. So we know we have pi r squared. Now, the triangle is base times height divided by 2. So divide by 2, what's my base? That is 6 square roots of 3 times the height of 9. Okay, there is a trick to putting this in the calculator. Do not put in pi. For pi can just hang out, all it's multiplied to everything. So you just don't include it and put everything else in the calculator. It will work out perfectly. All right, let me show you. So the numerator is actually 3 squared. Go down, the denominator is a fraction itself. So 6, and you have second radical, put a 3 in it, times a 9, oops, times 9. Okay, then divide by 2. Okay, that is fine without the pi. Okay, now push enter. And there you go. That is what you need with pi put in it. Okay, all right, so that will be with pi. That is option C. But I do need to show you something. Okay, be very careful. Okay, let's say you do this all by hand. Okay, this is what you're going to get. You're going to get pi. Okay, and then 3 squared is 3 times 3. Okay, now let's look at the denominator. Well, that is 6 divided by 2. Okay, think about it. That's really what we have going on. Okay, and that is times a square root of 3. And that's times 9, which is 3 times 3. Now, I'm going to start canceling things out and show you what I have left. Okay, The threes will cancel. The threes will cancel. Okay, that's good. Now, what's going to happen here? This 6 divided by 2 is 3. Okay, now let me clean it up and show you what we have. We have pi over, see, everything's marked out except 3 square roots of 3. You're looking at that. You may have done that by hand. And then you came to watch the video and you saw me use a calculator and you're like, uh, that's not the same thing. Actually, it is. Remember, when we're solving things with square roots, we do not want a square root on the bottom. So in order to solve that situation, they used a conjugate with the denominator. Okay, they used a conjugate situation, or rather, not a conjugate. They multiplied the denominator by the square root of 3. Okay, I that wouldn't be, well, it's just a way that we multiply to get the square root on top. Let me show you. Square root of 3 over square root of 3. I'm sorry, conjugate was absolutely not the right thing. What we're doing is multiplying by 1. Okay? All right, so now look at what happens. Well, here, I'll put it down here so we can see what's going on here. Okay? All right, so let's see. Well, I have pi square root of 3. Okay, that's what C has. And then square root of 3 times square root of 3 is 3. And 3 times 3 is the 9. That's all they did. Okay? All right. And if you're not sure, you can put that in the calculator, this part right here. Put all this in the calculator and see what happens. Okay, now you're gonna have to, well, we'll try it with a pi and see what happens. It may bounce us back to a decimal, and then we'll have to take the pi out to actually see it. Okay, so let's give it a go and see what happens. Let's clear that out. Okay, so let's set up the first fraction, and I have pi over 3 square root of 3, and then I'm going to multiply that to the fraction of, wrong place, wrong place. I wasn't paying attention to what I was typing in. I needed to second radical 3. Okay, go back over again. Okay, you have to do that enough. Okay, there we go. So now we're multiplying by 1. Okay, but we need to get rid of that square root of 3 in the denominator. It's just not, it's mathematically inappropriate. Yes, it is a valid answer, but it's still mathematically inappropriate. Well, they have an option C, and what the calculator gave us was appropriate. Okay, so second radical 3 over second radical 3 and enter. Yeah, it gives us that decimal that we had prior. All right, so let's go back up and capture it. Instead of pi, let's put in 1, because what we're doing is we're just multiplying by pi. Let's see what happens. Okay, enter. And there you go. That's what they did. They just simply use this little trick to get the square root of 3 in the numerator. Okay, and if you've taken trig, if you've forgotten from trig, that's what they tell you to do when you're talking about the unit circle. Okay, all right, let's go to number 7. And then we have, okay. A seven-sided die is rolled 3 times. How many outcomes are in the sample space? Well, that's just 7 to the third power. Remember, it's 7 possibilities, and we're going to roll it 3 times. Okay, so let's clear that out. Okay, so 7 carried up to the third. Let's see what we get. 343, option B. Perfect. Okay. All right, so let's look at number 8. Ah, I see what they're doing. A seven-sided die is rolled 3 times. What is the probability of rolling an odd number with two of the three rolls. Okay, let's take a look at what that is. On the first one, how many odd, let's see, it says odd. Okay, and it's seven-sided. So that's going to be 1, 3, 5, 7. There are four of those, okay? So we need four out of the seven, okay? And this is a probability we're multiplying because it's implied that we're going to get odd on the first roll and odd on the second roll. Okay, at least two of them. And then something else on the third. We'll talk about that in a second. Okay, so again, that would be four out of seven. But what would you get other than odd on the third roll? Well, that would be even. Let's see, 2, 4, 6. There are three of those. Okay, so we just need to multiply all that together. Wait a second. We already know what the total outcomes are. 7 to the third power. So we could do this. We could say 4 times 4 times 3 in the denominator and bounce down. You can put this, the answer from B, 343, or you could say 7 carried up 3. Either way, okay, but we know what's going to happen as far as the denominator. Okay, so let's enter. There you go. Let's see. That is option C. Okay. All right. This is the last question in this video. Thank you again for watching, liking, and subscribing. It is greatly appreciated. And don't forget to visit our new website at numbersarenadical.com. Happy testing, everyone.